In this topic, we're looking at linear momentum, or just you can refer to it as momentum if you like. And on the key concepts page, I've listed here the definition of momentum, but I've stated over here on the board for clarity that we're using the symbol P with a vector symbol over it to mean the momentum. In other words, momentum is a vector quantity, and its definition is mass times velocity, where velocity also is a vector quantity. And in that sense, you could say, like, well, hey, if I have an object that is moving with a particular velocity, what direction does this momentum point? Well, it's going to point in the same direction as that object's velocity. Basically, they're going to have that same direction. But the difference between the two is the momentum multiplies the mass to the velocity, or you could even say the speed if you're just looking at magnitude. So in that sense, momentum has more in it, you could say, maybe more information in it, although I don't know if that's quite right to say it that way. But momentum, from another perspective, you could say, is a measure of motion. In other words, it's telling you how much motion an object has in a way that is maybe different than if you simply knew the object's velocity or speed would, because clearly if you have a very large object moving at a particular speed, let's say you have like a huge truck going at 30 miles per hour versus a maybe really speedy cyclist going at 30 miles per hour. And if you ask, well, which one is really moving more? From the perspective of speed, you could say, well, they're moving at the same speed. But since the truck clearly has more mass, it makes sense that maybe there is more total motion involved in that system. And so that's the way in which momentum really is a measure of that motion. Now, moving down the key concepts page, we also have this formula here that says delta P, which I've written up here that delta always in science means change, right? So I've just written here momentum change, but you could also say change in momentum if you like. It's really final momentum minus initial momentum. That could be subscripted differently, like I could use a final subscript or an initial instead of P and P naught, but I find sometimes this one's simpler, but I switch. And using the definition, it actually makes sense that the change in momentum of an object with a particular mass m is going to be mass times the change in velocity. The last statement here, we're going to look at one last example in this topic that will explore the relationship between force and momentum. And I've stated here kind of at a conceptual, maybe broad conceptual level, that force causes momentum change. More specifically, though, you could say that net force is equal to the rate of change of momentum. And it turns out this is a restatement of Newton's second law. So we know that Newton's second law is net force is equal to mass times acceleration, but it turns out that's actually equivalent to this, and we're going to explore that connection in the last example for this topic.